Alright, you are watching this in order to help you out with synthetic division. I know that we started this before break, so it's been a little bit of time before you guys have seen this. So I'm just going to go through the presentation again, kind of refresh your memory. Alright, synthetic division, the reason that we do it is to break down polynomials. So if I've given you a root, or there's one that you can identify on the graph, then you can break down that remaining polynomial and find everything that's left. Find the other roots that haven't been found or haven't been given. It looks weird, not going to lie to you, but it's really efficient, and it's probably the quickest way to find all the roots of any given polynomial. Alright, so if I gave you this function here, 8 minus 4x squared plus x cubed, we need to find all of the roots of this thing. So I'm going to go ahead and write it in standard form, which is where you write the biggest power first, and then you write each power smaller after that. So I would write the x cubed first, and then the x squared term, the x term, and then the 8. Alright, now that's written in standard form. The degree of the polynomial is 3, because that's the highest power. Now, since its degree is 3, its leading coefficient has to be 1, because the term that gave me the degree, the coefficient for that, is going to be my leading coefficient. Alright, now this isn't hugely helpful right now. It's just vocabulary we have to have built in. Alright, so first we're going to look for a root. We should be looking for one which is easy to find on the graph. So like nice even integers, 1, 3, negative 4, 0. It's not going to be easy to see like negative 1.3 because things can just get crazy. It could be negative 4/3, or it could be negative 13/10. You know, we're not sure exactly what it could be, so we need to be conscious of the things that aren't so easy to identify. Alright, so here's a picture of the graph. It looks to me like there are 3 roots, 1, 2, 3. One of these is easy to identify, obviously, and the other one isn't. Well, we can't tell exactly what's going on here. It looks like negative 1.2, 1.3. This one here, can't exactly tell what's going on here. It looks like it could be like 3.2, 3.3. We don't know. But we know that that root is at x equals 2. Okay, we can say that confidently. Now, another way to express this is f of 2 equals 0. So if I plug in 2 to the original equation, x cubed minus 4x squared plus 8, I will get 0. Alright, so polynomial is in standard form, x cubed minus 4x squared plus 8. I know a root, and now I can begin the division. So the first thing I want to do is list all the coefficients. So I don't see an x term, I see x cubed, I see negative 4x squared, I don't see an x, but then I see the 8. So I'm going to rewrite this to where there's a 0 in front of the x. I'm really going to need that placeholder. So if the degree is 3, I'm going to need to have a thing that starts with the third, goes down to the second, and then just the x, and then the constant. Alright? So I list all the coefficients across here, but first I have to put the root in the box, which I found was 2. Right? It hits the x-axis at 2. So I list the coefficients in order across the top. So there's my 1, negative 4, 0, 8. Alright. So now I'm going to set up, I had the division set up, so here's how I do it. First thing I do is I take that first coefficient and I move it down. I always do that. Okay? That's just the first thing we always do, autonomic, first thing we do. Alright, next thing I do, I slide that 1 up to the 2, and I multiply them together, and I get 2. And now that 2 slides back under the 4. Now I add those together, and I get negative 2. Same thing as I did with the 1, take the negative 2, slide it up to the 2, multiply it out, I get negative 4. That slides back under here. 0 plus negative 4. It's going to be negative 4. Do the same thing with the 4. Slide it up. Multiply it. Negative 8. Slide it back. And I add it together. 0. Now, if the root was actually a root, and if I listed the coefficients correctly, and if I can add and subtract and multiply, or if I can add, subtract, multiply correctly, I should get 0 as the last thing here. Okay, that's called the remainder. Alright. So, I'm going to take the degree and subtract 1. So I started with a degree 3 polynomial, right, because this was in front of x cubed. And now I subtract 1 from it. So now this thing here is in front of x squared. And then this thing here is obviously in front of x, and that's my new constant. Alright, so I've got x squared minus 2x minus 4. So, I need to find these two roots. I know what the other one was. And the equation will tell me those roots. So I know that this thing here will hit at those exact points. I just got to solve this equation. So x squared minus 2x minus 4. How do I solve that? I'm just going to go straight to the quadratic formula. Okay? So there's my quadratic formula. I'm just going to go ahead and plug stuff in. Alright, and this I'm going to leave you to do on your own. Well, a is 1, b is negative 2, c is negative 4. I'm going to leave you to kind of work all this out on your own. But you kind of get the idea here. So I get 1 plus or minus the square root of 5. So one of the roots is at 1 plus the square root of 5, which is at 3.23. The other one is at 1 minus the square root of 5, which is negative 1.23. So now I know all of these roots, about negative 1.23, which makes sense. That's pretty accurate considering the picture. This right here was x equals 2. This right here is x equals 3.23. Right? So this is how we use synthetic division to find the remaining roots. Given a polynomial, we need to start with a polynomial, write it in standard form with all the placeholders and everything. Take a root. Take a root. We use that root in synthetic division, and then we find the remaining polynomials using quadratic formula or factoring or whatever we may need. Alright, good luck on solving the rest of these problems. You should be using this and other videos as a reference.